This is Mr. Hartman recording for the review for the test. Evidently, the software kind of had a bug in it last time, so it messed it all up. So I'm going to do this, and hopefully some of you will benefit from it. So the first question that we did on Wednesday, I guess, is this idea: which material is a poor insulator? So if you want to pause your video and guess, I'll let you do that. Okay, so we will just kind of go through that. Which material is a poor insulator? Well, we've learned before that feathers and air and plastic are good insulators. So these three are all good insulators. So we'll label those that way. So they're insulators. Iron. Iron is a type of metal. And basically all metals are good conductors. That means they let heat flow well. They let heat flow through it easily. So that's why it would be poor insulator. Good conductors are bad insulators. That's just how it goes. They're opposites. Alright, now which temperature is most related to, which of these is temperature most related to? So I'll let you pause it and guess. Okay, so for our answer, we said before that temperature, think about what a temperature is a measure of. Temperature is the measure of average kinetic energy. So, but if that's the definition of it, all it does is it measures kinetic energy. So obviously kinetic energy would be the best. A lot of you put thermal energy, a lot of people put thermal energy, but we have to remember that temperature involves just kinetic. Thermal energy includes two types of energy, both kinetic and potential. So that's why temperature is not most directly related to thermal energy. It's directly related to kinetic. So let's do this one. I'll let you guess this one, which is energy that is transferred between objects due to a temperature difference between those objects. I'll let you pause it if you don't know. Alright, so we are going to think about this. Energy, a type of energy that is transferred. Okay, so I know a lot of people put radiation and conduction, but both of these are ways to transfer energy. So that's, if they're ways to transfer energy, they aren't energy in and of themselves. And we said it is energy that is transferred. We talked about heat being, that's exactly what heat is. Energy that's transferred. So, by definition, heat would be the right answer. Radiation and conduction, they are ways to transfer energy, so, but they're not actual energy. Insulation, most people were alright with that, so we'll just move on. What statement is true? Thermal energy and temp are the same thing. Temperature is part of thermal energy, or thermal energy is part of temperature. I'll let you pause it and guess. Okay, thermal energy and temperature are the same thing. Most people knew that was not true. We just said in a previous question, right? Thermal energy is both kinetic and potential. And temperature is what again? All right, it's just kinetic. So if temperature is just kinetic, but thermal energy is kinetic plus the potential energy, wouldn't it make sense that temperature is part of thermal energy? Thermal energy includes a lot more than just the kinetic energy. It involves also potential. Therefore, thermal energy is not part of temperature. Which term describes the measure of average kinetic energy of the particles that make up an object? So, key thing there. I'll let you guess. Okay. We have said before, actually on a couple slides, temperature is the average kinetic energy. It doesn't involve potential energy at all. And because potential energy is part of thermal energy, we also know that it can't be thermal energy either. What's specific heat anyway? Specific heat is the amount of energy that it takes to heat up 1 kilogram of stuff by 1 degree. The amount of energy to heat, whoa, that's glitching out here, to heat up 1 kilogram of stuff by 1 degree Celsius, or 1 degree Kelvin, because they're the same size, and my tablet isn't letting me do that, but 1 degree Kelvin. Okay, degree Kelvin. So again, temperature is the average kinetic energy. That's the definition of temperature. Okay. What type of energy transfer does not require matter? I'll let you think about that one. What type of energy does energy transfer does not require matter? Well, let's first look at conduction. Conduction is transfer. One way we could say conduction is transfer by touch, right? A pot won't burn you unless you touch it. That's conduction. Convection is transfer. How? Convection is transfer by bulk movement. Transfer by movement of gases or fluids. Gases or liquids, so that includes fluids. Gases and liquids are both types of fluids. Well, in order for things to touch, there has to be matter there. So you need matter in order for matter to touch, right? If you need stuff to touch in order for conduction to happen. So conduction requires matter. You need stuff to touch. Convection, you need fluids. Fluids, gases, and liquids are a type of matter, right? So you can't do conduction without matter being, namely, gases and liquids. So radiation is the only way. And actually, it goes best through, I spelled though, through empty space. Okay, so radiation not only does it not require matter, it actually works best when there is no matter. So best through empty space, no matter. All right, this one might take a little bit of thinking. A 2 kilogram block of which material would require about 450 joules of thermal energy to increase its temperature by 1 degree Celsius? Now, in order to answer this, you might want to look back at what we said specific heat was just a couple slides ago. So I'll let you do that. Go and pause it and look back if you need to. Alright, so 2 kilogram block. So we are told that there's 450 joules of energy into 2 kilograms of stuff. Okay, we don't know what it is yet, but and my tablet isn't letting me do this, but 450 joules into 2 kilograms of stuff, and it wants to increase it by 1 degree Celsius. So you have twice as much matter as what a specific heat indicates. So this is for 1 kilogram. Specific heat is just for 1 kilogram. Well, we're told that we're heating 2 kilograms. So we can basically just cut that in half to find how much energy it would require to heat 1 kilogram of stuff. So 450 joules divided by 2 equals 225 joules. So then we can look at that and say, alright, where is it close to 225? And it looks like 10 is the right answer. Now some people put zinc because it was the closest to 450, but we're talking about 2 kilograms of stuff. So if we're wanting to heat up 2 kilograms of stuff, that'd require over, I'm just doing mental math here. It would require over 750 joules, not the 450 that we're told. Okay, so in order to heat it by 1 degree. So there, moving on. This one should be a little bit easier. Which material would require the most heat to raise a 5 kilogram sample of the material from 10 degrees Celsius? I'll let you think about it. Go ahead and pause it. Okay. Well, all we have to do, we don't even need these numbers really. It was just kind of throw you off. The material that would require the most heat to raise it by so much is the one with the highest specific heat. That's the definition of specific heat. I guess we don't have to go over that definition again. You can look back at what we said before on a few slides ago on what specific heat was. So, therefore, zinc has the highest specific heat. Therefore, it takes the most energy to heat it up. Which of the following types of thermal energy transfer is primarily responsible for heating water in the bottom of this pot? Okay. What's the thing that directly heats this water up? The water at the bottom. Okay. So I'll let you kind of think about that a little bit. Pause it and think about it. Now, the reason I said bottom is because, I mean, a lot of you could kind of choose conduction and convection because, yes, water is heated through convection, for sure. But how does it primarily get heated? How does it get heated at first? How does the hot stuff that rises get hot in the first place? Well, that is by conduction. The burner heats up the pot by conduction, and the pot's touching the water too, right? So the pot heats up the water all by conduction. Okay. Now, after that water is heated up at the bottom, then sure, you do have a lot of convection going on too. So, but primarily at the bottom of the pot, it's heated by conduction. How about the water in the top? I'll let you think about it for a second. Pause it if you want. Now, the water at the top isn't touching the metal, right? So the water at the top, and here's the bottom. So in order for the heat to get to the top, guess what? Yeah, we have to have a ton of water come up here so it can heat it. So yes, this would be by convection. Okay. Let's go to the next one. What is the transfer of energy by bulk movement of water? Now, a lot of people didn't understand what bulk means. Bulk kind of means all together. So, a bunch of stuff moving together, in the same way. So, what is the transfer of energy by the bulk movement of matter? It's literally changing location. So go ahead and think about that one. Pause it if you need to. Alright, well, if you chose convection, that would be right, because, you know, let's say you have a pot here, you have a bunch of hot water, right? And that hot water is all going to want to rise in bulk, and then it's going to replace this cold water. Well, that cold water replaces the hot air, so hot water. So you have this bulk movement. All this cold water is moving down, all this hot water is moving up. That's why we call it bulk movement of water. Yes, conduction is caused by the particles kind of going back and forth like crazy, right? But they're kind of more ramming into each other rather than moving all together as one unit like convection does. So that's the difference between those movements. You have in this section, you can easily have millions of little particles in this one area that's moving up. That's why we call it bulk movement. Okay. Through which of the following will convection most likely occur? Let you think about it. Okay. We have said before that convection has to happen in fluids, right? Well, can solids kind of flow fluidly past one another? Of course not. So all of these ones that include solids can't be right. We have to have D. Liquids and gases are used in convection. That's classic what we've been talking about a lot. We saw that in our labs. We did a couple convection labs, so we should know that liquids and gases are the only modes by which convection can occur. Which is a transfer of thermal energy through direct contact of particles. Let you think about it. Okay. So we've said that radiation, it doesn't even need matter, and convection is more by particles moving in mass. And it's working. This thing's pretty glitchy, this pad. But anyway, so conduction, we have said it's transfer by touching. In other words, direct contact, right? So that's why conduction is the correct answer. Alright, when a coat is put on the winter, the heat flow. Now I want you to, the heat flow from the person does what? I'll let you pause it and think about it. Alright, what is heat? Well, we've said before, heat is energy that's transferred, right? Well, what does a coat do? A coat keeps heat in. In other words, it stops. A coat stops heat from flowing. From flowing outward, I guess. Outward from your body. So, if a coat stops heat from flowing, wouldn't that make sense that no, it's not going to stay the same? Definitely not going to increase. If it increased the heat flow from you, you would get a lot colder because all that heat is leaving you. So the actual correct answer is that heat flow from the person decreases. That coat kept heat from flowing out of you. Water makes a good coolant because it has a what? Alright, we'll get into this. Water makes a good coolant because it has a low freezing point. Well, no, definitely not a low specific heat. Water actually has a high specific heat. Again, specific heat is amount of energy it takes to heat something up. So it can absorb much energy and have a low temperature change. So something with high specific heat doesn't heat up very quickly when a lot of thermal energy is thrown into it. That's why a pool is it stays a lot cooler than the beach will. Okay, the thermal energy of an object is what? Well, you should know this from what we've talked about it on a couple slides. It's kinetic energy plus potential. If it was just kinetic, average kinetic energy, what's that called again? It is called temperature. So that's that. And that was all the slides we had. Hopefully that helps in kind of solidifying some relationships and everything. Hopefully a couple of you can at least watch this. And I will sign off, and I'll see you tomorrow morning.